Good evening, everyone. I'm Hariram from Microsoft. Thanks for coming to this talk. Today, I'll be speaking about indexing in PostgreSQL, and it'll be a lighter take on the whole indexing aspect. So, I'll be talking about helping you navigate through the database jungle using various indexing options. Next. Okay. So we'll be talking about why we use indexes in the first place and some of the common indexes used, and also we'll wrap up with the best practices. This is going to be a very quick take on indexes. To be honest, I'm relatively new to Postgres and I love hiking. So I thought why not just marry the two concepts and come up with analogy to indexing and help understand indexing better. Typically, when a query is submitted to the Postgres query planner, it evaluates the query to make sure that the query is executed in the best cost optimal manner. So for this, it takes into account the indexes, the table statistics, and the structure of the query itself to make sure that it's executed in the best possible way. So why do we do this? We do this because we want a quick and efficient search of the Postgres database. Even when you're lost in a jungle without the map, it's going to be it's going to take a long time and it's going to be tedious to find a way out of the jungle. Similarly, when you're searching for anything in the database or sorting, it's going to take a long time. And this is where an index comes in. Think of the index as something like a GPS or a guide, which helps you away through the database forest. And it points you in the right direction and basically tells you where to look, where to find what you're looking for and how to find it. And I'm be touching upon three commonly used indexes, you could say, the B trees or the balance trees, hash, and as well as vectors. The B tree index is what I call the Swiss Army knife. So this is useful in almost any forest, not near an airport, but in any forest. And yeah, and it's not allowed in as a cabin luggage in an airplane, but you can take it anywhere, and in any forest you can make yourself way out of it if you have a Swiss Army knife. And true to that, it's very versatile. It has balanced performance and it's widely supported. And in fact, it is the default indexing method used in Postgres for a wide variety of data types. And wherever you see comparison operators, such as what you see on the slide, the Swiss Army knife or the B tree index is typically your go-to. And I've shared an example as well, like how do you create B tree index. There are some limitations, of course, for very specialized data types or complex data types. Maybe B tree's index is not the way to go. But by and large, for the most part, B tree index is a good bet. And coming to the other part is, in case you don't want a wide variety of, you don't want to sort your data or you don't want to do a range scan, then the hash indexing is the way to go. So what it does here is, if you want an equality search, you know exactly what you're looking for. For example, you have a list of user session IDs who are logged into your website and you're looking for a particular session ID. So all these session IDs converted into a hash using a 32-bit hash, and you can just specify the hash you're looking for, and you get the exact record which you're looking for. So hash typically is, as you can make sense of it, is that it works for smaller databases. So as the database size increases, the recall or the time required to search, it also increases. So hash is a good option if you have a small database and you know exactly what you're looking for. And finally, I would touch upon PG vector. As you know, AI is the new buzzword, and a lot of AI apps are being built, and we need data to power these apps. And how would you power these apps from PostgreSQL? So this is where PG vector comes in, and PG vector is used to store, index, and query high-dimensional vectors and vector data. This in turn is used to drive recommendation systems, text classification, NLP systems, and also image recognition engines. And when it comes to indexing, the two most popular types of indexing used with vector data is the inverted file with flat compression, or IV flat, and hierarchical navigable small words, or HNSW. Both these, depending upon, again, as we saw with the previous two indexing methods, depending upon the type of your data, you can choose any of these indexing methods. The IV flat is, the index is faster to build and it takes up less memory, but the query performance is average. So the speed recall value, if you consider, it's average. The HNSW takes a longer time to build and a lot of memory as well, but the query performance is much better. This speed recall value is much better. So whichever indexing option you go with, and when you build with Postgres on Azure, there is full support for PG Vector, for example, and we also have the Azure AI extension, which we heard about a lot in the last couple of days. So combined with PG Vector and the Azure AI extension, you have a complete seamless end-to-end experience for building AI apps on Azure. Yeah, and finally coming to the best practices, whichever type of indexing you choose, there is always going to be the best practices involved. So as you saw, like you have different types of indexes based upon the data, and based upon the type of data, you choose different indexes. And yeah, similarly, you would have to perform your maintenance, your vacuum, and monitor your CPU and disk usage parameters to make sure you're on track. All right, thanks. This is my last slide, and thanks for coming to this talk. Our Microsoft booth is still there, and we'll be there till closing time. So if you have any questions, feedback on this session, please feel free to stop by. Thanks, everyone.
Awesome, thank you.